Welcome to the Calumet Roundtable. I'm your host, Tom Roach. I'm joined by my guest today, Dr. David Pick. We're going to discuss heuristic versus rational problem solving. It's something that might help us understand the election that's coming up, and it has some inferences about artificial intelligence and some of the directions that that's going in. And it's also useful if you happen to be training a horse. David has his PhD from the University of North Carolina, Chapel Hill in experimental psychology. David, welcome to Calumet Roundtable.
Oh, thank you very much. May I call you Tom?
Yes, you may.
Oh, very
yes.
good.
Let's define our terms for our viewers here. So the difference between heuristic problem solving and rational problem solving. Get us started with that.
Well, a heuristic is a rule of thumb for problem solving, as opposed to an algorithm.
Okay.
But this really comes in context with economic theory, where traditional economic theory states that we do things to maximize our benefits and decrease our losses or minimize our losses. But there are all kinds of situations in human behavior where this just doesn't hold at all. Okay, let's say you're buying a car.
Right.
Okay, and you're looking at different important variables like performance and cost. Okay,
Right.
and you look and you look and look, and then you buy a car, and it's red.
Right.
Okay.
I bought that car.
Yes.
It was a BMW.
Yeah. Well, that's another reason to buy that car.
Yeah.
Yeah. Not necessarily the most rational thing to do or the most cost-effective.
Right.
Okay. But it's a very human sort of thing.
Yeah.
And my interest in this sort of thing really stems from something that didn't make any sense to me at all.
Yeah, this is an experiment that you did some 30 years ago originally, right?
Really. It was when people thought that horses and domestic animals in general were colorblind, that they couldn't discriminate between colors. I was at a small school in Georgia with $100 for doing research and trained in human memory. And
do they call that a grant at $100?
No, just go buy some paint.
It was a tip.
Yeah. Well, $100 would buy more than it will now. But it was enough to buy what I needed to do an experiment. Now this particular college was in the North Georgia mountains. It's still pretty warm in the summer.
Yeah.
And the campus didn't have air conditioning in the dorms, so there was no summer school. It was also on the quarter system, where you taught 4 classes a day, okay? So there was no time to do research except for in the summer. But they had 80 horses. This is a school where you could bring your horse.
Great.
It sounds pretty cowboy, but a lot of the students were riding to the fox, or riding to the hunt, I should say.
I see.
Yeah, it was, they didn't drive.
A little different from campuses that the rest of us are used to.
Right.
Go ahead, yeah.
They drove Saab convertibles.
But you had access to horses.
I had
as a result,
access
right?
to horses,
Okay.
yes.
And so
I designed this experiment. I mean, I had anecdotal evidence that they could discriminate, that a horse could tell the difference between a particular shade of blue, the school color, and other colors.
Yeah.
So I did a library research, and I found 2 empirical reports that said that horses were trichromats, one out of Germany and one out of Russia. Trichromatic meaning that they had the same color vision as humans. Okay. And there was a report out of Belgium where some veterinarians had flash lights into sedated ponies, the eyes of sedated ponies, and recorded their retinal responses. And they got slow responses from rods, as you would expect, but they got quick responses from cones. And flash, you get a very quick response, which indicates that they had cones, which are the basis for color perception.
Okay.
So I had $100 and a horse, and actually 2 horses. And I set up an apparatus in a pasture and set up some experimental stimuli, different colors, and trained a horse to go to this berry blue, to this color of blue, and not too gray, and I had the
So if
intense.
you went to blue, we got a reward. If you
When we
went
got to
gray,
blue,
we
got a
a
handful of Farmer Brown's horse feed.
reward. That's exciting, yeah.
It is exciting. It was for the horse, for sure.
Yeah, yeah.
Okay. So anyway, before too long, this horse would go to any shade of blue
Yeah,
compared to any shade of gray. It wouldn't matter which side
right.
the choice was on. And
So
this
your
is under.
immediate concern here is addressed at this point, right? Because you're showing that they can distinguish
Oh
between blue
man,
and
I'm
gray.
saying this Russian and this German are right, and all these
Yeah.
people have been saying that domestic animals
Right.
are colorblind are wrong.
Right, right.
Okay, but this is easy to talk about, but it took, I would say 9 months to a year
Right.
to train this.
Right.
Okay, so I've got other colors set up that are matched. All right,
Yeah.
so the next color I tried was red. Okay. And I figured, why mess around with all of this shaping, this method of successive approximation and the training to get it to do that? So I just took the red stimuli and replaced them for the different shades of blue that I'd used previously against the same grays.
Right, so logically, you're thinking that the horse is going to go to the red
And not the gray.
because
why?
it learned that the gray is bad, right?
Really? Anytime the horse went to gray, instead of getting some horse feed,
Yeah.
it was brought back to the starting post and had to stay there for another minute. Okay?
Yeah.
Which is not something the horse appeared to like very much.
Right, because they want to eat.
Yeah. So anyway, so I replaced these blue stimuli with
Yeah.
red stimuli, and what's this horse do the first 20 times it's given a choice between red and gray? It goes to gray 20 times in a row.
Yeah,
I mean, I immediately knew that the horse could discriminate or tell the difference.
yeah, definitely, yeah.
But it wasn't doing what it was supposed to do.
Right.
Okay. So I had to go through,
So now you're wondering, why is it going to gray?
and I wondered, why did it go to gray? That's 20 times in a row. Due to chance alone is 1 in a million.
Yeah.
1 in a million. Okay. So I spent all this time reshaping the horse to go to red, and finally the horse did what I wanted to do and went to red and not to gray. But for 20 years, I'm scratching my head wondering, why is this?
Yeah.
I mean, reinforcement theory, any kind of behavioristic reinforcement theory, like traditional economic theory,
Right.
would say that the horse would perform to maximize its benefits
Right.
and minimize its
Right,
losses, and
right.
it wasn't doing that.
So led you to a new hypothesis, right?
Right. I was reading a book written by Daniel Kahneman called Thinking Fast and Thinking Slow. It's basically based on the idea that we have these rule of thumb problem-solving techniques that probably run through the phylogenetic scale that allow us to make decisions quickly and most often accurately with very little
Right.
expenditure of energy or thought.
Yeah.
Okay, they're adaptive, and if they are adaptive, they should be passed on to other generations.
Right.
Okay, so one of these heuristics is something that you're familiar with as a voter. Okay.
Yeah.
People put signs in their yards, don't they?
Right.
Or politicians have people put signs in their yards.
Yeah.
Now, why do they put up signs?
Well, from the perspective of the campaign, it's to show that there is a groundswell of support from your neighbors. And so people fearing alienation, right, will want to side with the same candidate that their neighbors are siding with.
Or could it be that the more often you see this name, the more likely you are to remember it and the more familiar it's going to be to you?
So this is and so now we're looking at the alternative here, right? So
Right.
there's this rational approach to problem solving that
Right.
says, I'm going to vote for this candidate because he supports, free college educations, and he, takes a stand that I like on free trade or something, right?
Right.
Or I'm going to respond to this heuristically and say, I'm going to vote for the candidate I'm most familiar with, right?
Right, and that would be one of many biases you
Yeah.
might have in
Yeah.
terms
Now
of
that, interestingly enough, was the basis of Nixon's first campaign in 1968. They hired, I think they hired the guy who ran the Ivory Soap campaign. Ivory Soap had a campaign in the 60s. this was your mom's soap, I think, was kind of the theme. This is the soap you're familiar with. It's the it's the safe soap, right?
Yeah.
And so when they were trying to figure out how to pitch Nixon, because he'd had alienated himself from
Sure.
the voters a couple times in the past, right? They decided they were going to present him as the familiar, tried and true candidate, essentially, right? And they ran an advertising campaign based on that theory, essentially.
Let's see.
So you're saying your horse, because we're going to wrap up this part of the interview here, but you're saying your horse went to the gray not because
it paid off.
it paid off, but because it was the most familiar.
It was
right?
the most familiar.
Yeah.
That's what I'm thinking.
Yeah,
And that's why I'm working with horses again,
yeah,
to see if this holds up across a number of different stimulus situations or choice situations.
yeah.
And my students here have already replicated the color experiment.
Okay. All right, very good. We're going to take a quick commercial break. The Calumet Roundtable will be right back. Welcome back to the Calumet Roundtable. I'm your host, Tom Roach. My guest today is Dr. David Pick, and we're continuing our discussion on heuristic versus rational problem solving. Dave, what does a horse experiment lend to our understanding of heuristic problem solving?
Well, actually, the heuristic I'm working with, the familiarity bias and the choice determined by familiarity, is something that the author of prospect theory, the theory that I am evaluating, would predict runs down through the phylogenetic scale. Okay, so
And the phylogenetic scale, maybe we should.
Well, we're at the top, and like earthworms are on the bottom. Okay,
Right.
we're going to rank ourselves in terms of complexity, I guess. Intellectual complexity would be one way of doing it, but this is something that, if it is adaptive, could quite possibly be, if it's adaptive for us, and that's the argument, it couldn't quite possibly be adaptive for lower organisms as well, including horses. And what we're seeing, as I mentioned earlier, my students have replicated the color choice experiment, and right now they're working on a choice between geometric shapes, between circles and squares. And when that's learned, and there's a lot of experience with reinforcement for circles and none for squares, we'll replace the circles with triangles and predict we go to the squares. And when we do a similar thing with 3 different levels, intensities of tones, then it will be something that can be published, actually.
Yeah.
Right now, it's only been conference presentations.
Yeah. Now, the work with artificial intelligence is moving in this direction, is it not?
Oh, it certainly is in terms of heuristic. I think most
Yeah.
people are most familiar with computers playing chess. And Big Blue beating a grandmaster not too long ago.
Right.
And people generally don't know that 6 expert chess players were programming Big Blue between matches, to adapt.
Oh, is that right?
That's right. That's right.
Oh, that's
okay. But you know, with heuristics are often compared to algorithms for problem solving, where you check out every single possibility.
Well, that's what I always assumed the chess program was doing. It was just...
No. They're programming heuristics. They're
Really?
They're recognizing certain positions for, oh, you play chess. That's
Okay,
right.
so yeah, so I'm playing chess.
Right.
And someone brings their knight out, let's say, right?
Right.
And I'm calculating that, you know, if I don't make a counter move, 2 moves from now, that knight can fork my queen and my rook, let's
Sure.
say, right?
Sure.
And so I move to stop it. Now that's just a case of me being rational and figuring that out, okay? But if someone makes the knight move and I say, oh, I've seen that move before, I better protect myself against the fork.
Right.
Right? Is that more of a heuristic response?
That would be of a more heuristic response.
Yeah.
That and maybe 2 or 3 other or 50 other alternatives
Yes.
would be evaluated instead of every possible move.
So they're actually programming the computers to do,
Right. What
that.
people do.
no kidding.
Right. Or attempt to do what people do. Now, to program a computer to
Wait. Now, why is that better than having the computer just figure out all the options?
Oh, it couldn't. Not even Big Blue. No.
Right.
There's just too many possibilities. And as fast as a supercomputer is, you couldn't live long enough to check them all out every time there was a move.
Right.
It's just
Because technically there's an infinite number of variations
right.
off
Well,
of every move, right?
nobody's ever counted them, but
Right.
infinite's a good word for that, I think.
Yeah.
Yeah.
All right, there's a variation for every grain of sand.
Something like
In
that.
northwest Indiana. Yes.
Yeah. Yeah. So it really cuts down the number of possibilities you have to evaluate in making a decision or making a move in chess.
Yeah.
Now, when it comes to being human, we're much more emotional than that, okay? I mean, people right now are working with Go. It's not a game that I'm familiar with.
Yes, I think I read something about it.
Yeah.
That's the little
Little dots
beads or
on.
stones that you put
Right.
on a grid.
Yeah, that's about as much as I know about it,
Right.
except for that it's even more complex than chess. And that,
Well, I don't know.
that really, well, more possible moves, let me put it that way. But the people who are good at Go
Yeah.
don't think about it. They just react
Really?
in an intuitive kind of way. So people are trying to program
Yeah.
computers to be that intuitive.
Right.
And when they get that, I want to see them program emotion. When you talk about elections,
So is this moving us in the direction of being able to program emotions?
well, I think it would be a step toward that.
Yeah.
I mean, the idea is to have a computer that's human. Now, you've heard of the Turing Test. I know you have.
Yeah, tell us about it.
Well, this is Alan Turing. You've heard of him.
Yeah.
Enigma. He broke the Enigma code. There was a movie made about him recently,
right,
okay?
right.
Back in the 30s, before
Yes.
he died,
Yeah.
he said that computers, he was interested in artificial intelligence. He said that when you can interact with a computer through a keyboard
And not know.
and not know
That it's
whether
a
it's a
computer.
human or a computer, then his test for artificial intelligence would be passed. And nobody's done that yet.
Right.
Nobody's done that yet.
And I understand there's an award.
An annual contest,
yeah.
And nobody has done it yet.
Yeah. How's that set up?
Well, there's a keyboard and a monitor.
And the contestants are off-site somewhere,
They're in a different room.
and you have
And
a
the program's in a different room.
committee
Yeah.
or something that's...
I'm not sure. I'm
yeah.
not sure how.
and they always figure it out. Nobody's ever fooled them.
No computer has ever fooled them into thinking that
Yeah.
they were a human.
Yeah.
Yeah.
Interesting. So this heuristic versus rational problem solving, another thing that this connects to for me in rhetoric is this understanding of the syllogism versus the enthymeme. So the syllogism is where logically all of the steps that you need to take to reach the conclusion are supplied. So, Socrates is a man, all men are mortal, therefore
Right.
Socrates is mortal, right?
Right.
But the enthymeme, there's lots of ways of doing this, but the most obvious way is the enthymeme is a syllogism where you've left one of the premises out. So you say Socrates is a man, therefore Socrates is mortal. You don't have to say all men are mortal because we know that intuitively, essentially,
Okay.
right?
You don't have to state the premise.
Yeah.
Okay.
Yeah. So one of the interesting. Well, first of all, I mean, would you? Am I right that that's similar to what we're talking about here? That's a move in the more of a direction of heuristic problem solving when you're implying conclusions rather than spelling them out the path to
Well,
get
I
to
don't
them?
see the connection.
No?
there. I
Okay,
don't-
well, maybe
I
not.
don't. I mean, I could be wrong. I hadn't thought about that at all. But that knowledge about the missing premise would be stored in memory, would have to be stored in your memory, right?
Well,
to be aware of it.
right. Well, maybe we're looking at it too literally. So if I say, let's say you're asking me, I teach public relations, right? And
Okay.
we're talking about one of my students, and you ask me, can you write a press release? And I say, well, he's a public relations student. Now, I haven't said he's a public relations student. He took a class in news writing and then took advanced
Right.
PR, and we taught him to write press releases,
Sure.
and he published them and then graduated, right?
Or told me how good a grade he got in those classes.
Yeah, right.
Yeah.
But I'm just saying, I'm sort of like moving you in that direction without necessarily spelling it out. Is that?
Yeah. Well, I guess in a way that is
Yeah.
such because it's a simplified. It does
Yeah.
simplify a decision.
Yeah.
Okay. Can
Yeah.
this person write a press release or not?
Yeah.
Okay. And answer that question anyway. This is more of a bias.
Okay.
Based more on.
Oh, I see. So it's based more on tendencies that the listener has in this
Right.
case, right?
Right, or the decision maker if it's a voter. Okay,
Yeah.
now who are you most biased to vote for? Okay, I mean you have rational voters, but we're all.
You say that like that's an exception.
Well, I think it is. I mean we are humans. We're very emotional.
Yeah.
And if you look at recent elections, who is elected? It's the person who is liked. The person now, not necessarily for rational reasons.
Yeah, it
Well-
seems that way to me sometimes. Sure.
Well, no, I mean,
Whenever my candidate doesn't win.
sure.
Yeah.
Yeah. Well, that may be my bias as well.
Yeah.
Yeah. But if you vote for somebody because you could have a beer with a person, as opposed to their ideas on foreign policy or economic policy or something like
Okay,
that,
so-
that's not very rational.
Okay, so who are the candidates that we could have a beer with right now? I mean, who's
Right now?
Who's making the greatest heuristic appeal from your perspective?
Oh, I think that the Donald is.
Yeah,
I think he is.
and because he.
Well, he's saying all kinds of things that people want to say and don't say them because they don't want to be rude.
Yeah.
You know?
Yeah.
There is a lot of frustration. I'm no expert by any means.
No,
okay?
it's interesting.
Yeah, yeah. Now, I really like Hillary,
Yeah.
but not for emotional reasons per se.
Yeah.
I like her. Should I be talking about my political?
Well, it's okay. I
Yeah.
think we're at a
Yeah.
public university here. I think we're allowed to have opinions. Right?
Okay, okay. I agree with her opinions and all that, and I
Yeah.
like her for that reason.
Yeah.
I don't.
You don't picture yourself having a beer with her, though.
I could have a beer with her.
You think?
I think I could.
I think it'd be more comfortable having a beer with Bernie, but.
Now, Bernie, definitely a likable character.
Yeah.
Definitely. And he's strong and true. He's been at this since the 60s. He hasn't wavered anything.
Right. No, he's got a lot of that going for him. I think that's pretty apparent. I think it's an interesting race to analyze along those lines. Now, a lot of people felt that Al Gore was it was just too hard for people to relate to him.
Right.
And he ran against George Bush, W., who also looked like he was a guy you could have a beer with, to use your analogy, right?
Yeah.
Do you think that was a factor in that race?
Oh, I know it was.
Yeah?
I know it was. I mean, if you point out to people why they shouldn't vote for him, they would say, oh, that's okay. I really like him.
Yeah.
I mean, that's anecdotal for sure.
Yeah. No. Well, this is really parallel with a lot of what I've read in rhetorical theory. Lloyd Bitzer says that, actually, it's kind of the argument you were making about chess. Lloyd Bitzer says that it's almost impossible for a voter today to track all of the issues that would be impacted by a presidential candidate. And so he believes that what happens is we gravitate to the candidate that we're most comfortable with, and we trust that they'll make the right decision when they need to. And so he thinks that we're really electing people based on their character rather than just on the issues and the positions they're taking.
Yeah. And I would say character would be just another thing to put in the equation.
In the heuristic equation, right? On the heuristic side, yeah. Well, that's interesting. So can you predict the outcome of the election for us?
No, I can't.
No?
No, I can't. I really don't. I have hopes. I have hopes.
All right.
I can't predict it at all. I mean, there are so many variables.
Yeah, no.
I mean, Donald could do something that really made people angry with him.
Yeah, you know, he could.
Or Hillary could,
Yeah.
or Bernie could, for that matter.
Even more entertaining than he has. Yeah. So just one last thing. Back to the horse experiments.
Right.
Are people still doing a lot of experiments with horses? And did that start because of the guy who had the horse that could count? And you know, can you give us a quick history of that?
Well, Clever Hans, you're referring to,
Yeah,
of course.
Yeah. So this is about 100 years ago, right?
Right.
Okay, we got 60 seconds.
Well, that horse that could add, subtract, multiply, and divide.
Yeah.
Hans, what is 2 plus 2?
Yes.
And how would he answer? Do you know the answer to that question? What a horse. Okay, and he could answer that question no matter who asked it.
And what we learned from that really was that the horse wasn't counting, right?
No.
And he wasn't giving the horse sugar cubes either, right?
Well, he was.
He was
For being right, but only when he was right. But he was always right.
Yeah, but he was right. And what we learned was the horse is actually reading his inflection and things like that, right? Or not?
His facial expression. The person who's asking the question would change expression in anticipation of a correct response, and the horse would frap out one more and be right.
Okay. That is all the time we have on our program. Thank you to Dr. Pick for joining us today on the Calumet Roundtable. I'm your host, Tom Roach. Have a great day.